Hi everyone, this is my submission for homework 2 for CS 441, where I will submit Spark jobs uh, to create indexes out of an incrementally changing corpus of PDFs using delta tables. So here I have a jar file from my code that I have uploaded already in S3, and this jar file is just made by compiling the code that I have over here in my source. And it also includes some of the configuration that I have added for this code. For example, this is the application.conf file that I have, and all the embedding model name and the version and the batch size, which is the number of texts to send to the Ollama model, and the host of the Ollama model is all configured in this application.conf file, along with the paths, both the HDFS and the S3 paths to find the text corpus, the warehouse to store the data, and other things. So let me first start by submitting the step to start the process. Before that, let's talk about the cluster itself. So I'm using a cluster with two instances of one core node and one task node other than the primary node, which are both M5.2x large, because these are sufficient enough to run the MXBI Llama embedding model. And now I'm going to start by and also this cluster has been bootstrapped using a bootstrap script, which I can show to you. Yeah, which is over here or in my repo actually. Yeah, so this bootstrap script just sets up the necessary Java versions and also ensures installations of Spark and Hadoop, and also ensures that Ollama is installed and tests and warms it up by testing the embedding endpoint and also testing if S3 is properly connected. So this bootstrap script starts up this cluster. Now let's start by adding the step. So to add the step, I go to Spark application, and at first I have from the configuration which shows the path of the text corpus. It is over here, and I have 10 PDFs uploaded as a sample from which I want to create the index for the first time right now. And this will create the first index, so it will create all the tables from scratch. So I will call this initial index job, and I will be running on cluster mode. And this S3 path is basically the path to this the jar file uploaded over here. And the options for Spark Submit. So these are some options that help Spark Submit work properly. For example, this Delta Spark extensions is what makes it store the tables in Hive, and also this Delta catalog, and also this a warehouse directory path, which tells where to store the files for storing the actual tables that I create in S3. So this is this path over here in warehouse. And some other packages and S3 related stuff. As for the arguments to my actual code, to my actual jar file, I have a reindex flag which tells it that I'm running it for the first time. So it's going to drop the tables and create everything from scratch. And an environment flag just to make it differentiate between S3 paths and local paths. So I'm going to start running this step. So as you can see that this particular step has been completed, and let's check out the logs for this step. So I'm going to check out the log from this application ID. Basically, in the logs folder for this cluster, I go to containers, and this is the application ID. And inside this, I go to one of the containers, and I will look at uh, the standard error log. Let's look at this. Let's look at the logs from my particular class. Yeah, you can see that it has logged all the things such as the run metrics, the number of documents found 10, number of bytes, how many actually embeddings that it generated, and the time taken, and also other stuff like number of entries, which snapshot path has it written to, and all these logs are put over here. Now let's actually check the results. So the paths that it puts into, let's first check the creation of the tables. So there's this warehouse folder that I mentioned earlier, and you can see that the tables have been created in this. I have delta embeddings, delta PDF chunks. We can actually look at the schemas of this table in the standard out because I was printing them. Yeah, so you can see that this is the columns for the delta PDF table, which is PDF chunks table. It has text, language, title, doc ID. For the chunk table, for the delta PDF chunks, it has the chunk ID, chunk index, start index, section path, then the hashes and the IDs. And for the delta embeddings table, it has the model name, model version, and the actual embedding. And yeah, and this is the actual retrieval index table. Uh, we can, so to look at that, since these are just Parquet files, we can look at that using AWS Glue. So let's look at one of those tables. For example, we can look at the PDF chunks table. We need Athena for that. Yeah, you can see this chunk index, and this is the actual chunk text and the content hash, and this table exists over here. So now let's look at a particular table, which is the actual retrieval index. That is a snapshot index that is created. Yeah, so you can see it has a chunk ID, document ID, the text that is there, and the language title and the actual embedding. So this snapshot then can be used for RAG search and other things. It also has the timestamp version and the version of the embedded in the model for which these embeddings exist. And also there is a metrics table that I maintained, which is this. So you can see for the run just which we just had, it had 10 documents scanned and 195 new chunks were created and a total of, yeah, 195 new embeddings were created, and these are the timings that it had. So this was the total time to read, total time to chunk, total time to embed, and this is the total overall time that the execution ran. We will use this to compare with the next runs that I do. So now let's move on to the other job, which to simulate an increasing text corpus. I'm going to upload two more PDFs in this text corpus. So let's do that. So now that I've uploaded two new PDFs, this simulates incoming new PDFs that I should be able to get to a new snapshot of index, including those new chunked embeddings. So now let's start running the step. So again, this will be a Spark application. I'm going to call it um, incoming PDFs job and cluster mode. And this is the same path to the jar file that is shown earlier. The Spark options remain the same as before. And this time I did not add the reindex flag because now this is an incremental job. I just want to add the two new PDFs, and the environment is obviously again EMR. So let's run this step. Okay, so now that this job is also completed, let's look at the logs. So the logs will now be in the next application ID in any container. Let's look at the standard error logs. Yeah, you can see that this time it scanned 12 documents instead of 10 and scanned these many bytes, but the only new and changed documents that are detected were two, and they only had 40 more chunks. So it only created 40 more embeddings uh, for the particular job, which means that it's not just redoing the entire job, just the changed or newly added documents. And so these are the logs. Along, let's look at the results in the Glue database. You can see that the newly created snapshot is also stored on S3. in the warehouse, you can see that another snapshot retrieval index is created. Now let's look at all of these in the glue database. So looking first at the actual newly created retrieval index. Yeah, you can see that earlier there was only 195 chunks, but now there's 235 chunks because 40 more chunks from the two new PDFs were added. And all the version information and timestamp information is also there in this newly created index. And also, you can see that, for example, in the docs, PDF docs table that I have, there are now, instead of just 10 documents, there are now 12 documents for the two newly added PDFs. So, yeah. And also looking at the run metrics, you can see for this new run, the docs scanned were 12, new docs were two, new chunks were 40. And also for the time taken, it was lower overall time taken because only two new PDFs were added. And yeah, docs skipped ratio is basically 12 docs were scanned, but only two were used. So the rest were skipped and not reused. And yeah, and the new snapshot path and everything. So now let's look at an example where I do not upload any new PDFs, do not change anything, and just run the job again. So zero work should be done as no new chunks should be embedded. So as you can see, I will keep the text corpus as it is, just the 12 PDFs from the last run and not change anything. And I'm just gonna rerun the last step as it is. I'm gonna call it no change run. And yeah, the same arguments, no reindexing, just running the same thing again. Yeah. So this job is completed. And so after the completion of this job, let's just directly go check the run metrics. And we can check it in the Glue database. Yeah. So if you look at the run metrics table, yeah, you can see that, wait, let me just order this. Yeah, so you can see in this latest run, there were 12 docs scanned, but there were no new docs and no new chunks. So there were no new embeddings created. And the time taken was much, much low. It was just, yeah, it was a negligible time compared to the other runs because there was zero work done. Yeah, so as there was no embeddings created and all the docs were skipped because they were the same docs. Yeah, and the new snapshot was updated. So this was a no change run. So now let's showcase what happens when you are just editing the PDF without changing its name and editing a small section of the PDF. So basically the work should be done only on the changed section of the PDF. So only those chunks should be re-embedded. And I'm going to showcase that. So uh, I have a PDF that I have edited myself. So the rest of the most of the PDF is still the same from the start, but I have edited part of the text over here. And to look at it initially, here's the difference. Initially, the original unedited PDF has 17 chunks. But the difference is that the edited PDF also has 17 chunks, but the last seven chunks are a bit different. So these should be rechunked and re-embedded is what I basically want to show. So first, let me go to S3 and delete the original. Okay, so now we have a PDF over there which has the same file name. So it should still show up on the table as this previous file name, but it is edited content. So now let's see what happens. After doing this, now I'm going to run the step again. Yeah, same options as before, no indexing, just running it again with the same options. So let's run it. Oh, and yeah, it's not called no change run. It should be called like editing change run. So as you can see that this application is, this step is also completed, which was just me editing the PDF. So now let's check the results. Firstly, in S3, uh, we should have the new snapshot for this timestamp. And also in the tables section, we will now have a fourth retrieval index. And now let's check out these tables actually in Glue. So Yeah, let me refresh this. Yeah, so we should have a fourth retrieval index, and we can check that out. Remove the limit. Yeah, you can see it just has the same number of chunks as before, with an addition of one new chunk because the editing might have, shifted the paragraph so that there's another chunk now. But yeah, this is basically the updated embeddings after editing the PDF. And to check the metrics for this, um, yeah, in the run metrics table. Okay, so right. So you can see that in the last run, there were 12 documents scanned, but only one change document was detected, which was one that I detected. And it detected that 17 chunks were there in the new document, but only seven new embeddings were created because, as I showed you, there were only seven chunks of the PDF that were changed, and 10 of those embeddings were reused. And somewhat the time taken was somewhat more than the no change run, but still pretty less. And yeah, so these are the metrics for me editing the PDF.